Hello everyone, my name is Torsten Åström and I used to work for Wartsila for over 21 years and I've been involved in building power plants using diesel engines all around the world. So I want to talk to you a little bit today about some tests we did with Nanol in these diesel engines that were driving big generators. What was important for me was to find a few test sites, preferably with different type of engines, different type of manufacturers, and that the test sites had very reliable fuel measuring equipment so we could very accurately measure the fuel consumption. Therefore, I picked two power plants where I had been involved myself in building these power plants in the past, and I knew the customers and I knew that they were very reliable fuel measuring equipment at these power plants, and I knew that these power plants were very well operated and very well maintained. Thus, we could secure very reliable data. One power plant was in the Dominican Republic and they had Wartsila engines. The other one was in Haiti and they had Hyundai engines. Both power plants were operating at very high load, so I knew that the engines were running under very harsh conditions. We started by using Nanol, and before that, if I may back up a little bit, before that, we actually took some measurements for a couple of months. We had reference data before we started using Nanol. Then we started adding Nanol. We added 3% into the lubricating oil, and then for a while we went up to 5%, but when we took lube oil samples, we discovered that 5% was way over the top, and the copper concentration rose way above what we felt that we needed to have in the lubricating oil to achieve the results. The fuel oil consumption was charted in all units very carefully on a daily basis, and we had charts that we analyzed on a daily basis, on a weekly basis, on a monthly basis with very detailed information. Now, when I show these heat rate charts also, what's important to remember is that these are base load power plants and they fluctuate a little bit with the load. So the load is not, let's say, 92% constant. It could be 91%, it could be 94%, it could be 89%, it could be 93%. So what you will see is that, the load fluctuates a little bit. So what's important then is that you look at the trend line over a longer period of time. I wanted to look at the trend line over 6 months because I felt over 6 months, looking at the trend line, it would give me reliable information on the fuel consumption, in which direction would it go. So that's what we did, and that's what you will see in the heat rate curves that I'm presenting. Now, typically also in a diesel engine, what you will see is that in between overhauls and service intervals of the engine, the fuel consumption will increase. You will see typically a heat rate increase or fuel consumption increase of between 0.5 up to 2.5% between the service intervals. This is quite normal. And what was interesting with this test with Nanol is that we saw, in spite of us running for a longer period of time, the fuel consumption actually went down, while at the same time on similar engines that were running side by side without Nanol, the fuel oil consumption went up, as was expected because we were in between service intervals. As you can see on slide number 3, where we had used Nanol in a Wartsila 18V32E engine, you can see the fuel curve, without Nanol and with Nanol. You can see the clear difference that the fuel consumption is going down in the engine that we're using Nanol. Slide number 4, you can see a Wartsila 12V32D engine that was running without Nanol. And then on the next slide, you will see also Wartsila 12V32D engine that was running with Nanol at the same time, and these are engines running side by side on basically the same type of load. they were sharing the load. So you can see the clear difference in fuel consumption, and the engine with Nanol had a fuel consumption that continuously went down. Now, what would be interesting to know, but I don't know yet, this is over a time period of approximately 6 months. At what point in time will this curve flatten out? And how much of a fuel consumption will you get over time? In this case, over 6 months, we recorded a savings of 2%. So the fuel consumption went down by 2%, which is significant. The next slide, you will see the heat rate curves for the test in Haiti that was using Hyundai engines. And you can clearly see that the fuel consumption is going up over time, as we expected it would be. This is quite normal. Except in engine number 3, which you will see on the next slide, where the fuel consumption is actually going down over the same period of time. So that's a very interesting observation. This power plant actually had 8 similar Hyundai engines. On all 7 engines, the fuel consumption went up, while the fuel consumption on engine number 3 that operated with Nanol, fuel consumption went down. Very interesting results. So what I think is important, and what we did, is that you have to run over a longer period of time so you get reliable data, and that's what we did in this case. And typically what we saw was a fuel consumption savings, a reduction in fuel consumption of between 2 to 2.5%. Which, again, that's a big savings in a power plant. Especially if you think that you have a power plant where your fuel bill is about $100 million a year. If you save 2.5 million, that's a great saving. That ends my presentation. I hope you can take a look at these fuel curves. If you have any need for additional information, if you have any questions, if you need to have any backup information, feel free to reach out to us, and we'll be happy to provide it. Thank you.